Hello, everyone, and a very warm welcome to another exciting, deep dive episode of our podcast. I'm Hari, your guide through the cosmos.
And I am Kimi. Today we are traveling to the freezing, dark outer reaches of our solar system, way past the orbit of Neptune, to explore a fascinating icy world that is as mysterious as its history is dramatic. We are talking about the incredible, bright dwarf planet Makemake.
Yes, Makemake. It sounds like a tropical vacation or a fancy dessert, but it is actually the fourth largest trans-Neptunian object and the largest classical member of the Kuiper Belt. This distant, frozen world was discovered on March 31, 2005 by the legendary American astronomical team of Mike Brown, Chad Trujillo, and David Rabinowitz at the Palomar Observatory.
That's right, and here's a wonderful fun fact. Its very first nickname was actually Easterbunny because they discovered it just a few days after Easter. The team used that as a placeholder. When they finally chose a formal name in 2008, they settled on Makemake, the creator of humanity and god of fertility in the myths of the Rapa Nui people of Easter Island, keeping that clever holiday connection beautifully alive.
I absolutely love that naming story. But the road to announcing its discovery was filled with pure, high-stakes scientific drama. The Discovery team originally planned to delay announcing Makemake until after they unveiled Eris later that year. However, their plans were completely upended when a Spanish team led by José Luis Ortiz Moreno suddenly announced they had found Haumea. Mike Brown quickly realized his team's logs had been accessed by that Spanish institution's computer.
Yikes, talk about space-age espionage. Fearing they would lose credit for Eris and Makemake next, Brown rushed to contact the Minor Planet Center on July 29, 2005, to announce both objects immediately. This sudden influx of Pluto-sized bodies sparked a massive global debate about what actually defines a planet, ultimately motivating the International Astronomical Union to create a new definition that famously demoted poor Pluto to a dwarf planet status.
So Makemake literally helped rewrite the astronomy textbooks. Now, in terms of physical scale, Makemake has a diameter of about 1,430 kilometers, which is roughly 60% the size of Pluto. Thanks to observations of a stellar occultation in 2011, we know it's a Maclaurin spheroid, meaning its rapid rotation causes it to flatten slightly at its poles. It is also incredibly reflective, with a geometric albedo of 82%, making it significantly shinier than Pluto. Its surface is dominated by frozen methane, which the New Horizons spacecraft studied from afar and suggested that its regolith consists of smooth grains resembling snow. It also has a distinct reddish-brown hue from tholins, which are dark, complex hydrocarbons created when solar ultraviolet light breaks down methane.
But what is really fascinating is what is missing from its surface. Pluto and Eris have plenty of nitrogen and carbon monoxide ice, but the James Webb Space Telescope recently checked and found that Makemake has almost none. Scientists believe that because Makemake has a slightly weaker gravity, volatile nitrogen easily escaped into space over billions of years, leaving the methane remarkably pure to grow into thick, dense slabs.
That makes sense. And because its surface looks so uniform, astronomers initially thought it was geologically dead. But recent James Webb data showed a very low deuterium to hydrogen ratio in its methane. This suggests the methane was likely processed in a warm, geophysically active interior, with temperatures reaching up to 150 degrees Celsius.
This indicates that Makemake could hold a subsurface ocean of liquid water, kept warm by radioactive decay in its rocky core. To back this up, in 2025, scientists argued that an unexplained excess of mid-infrared radiation coming from the dwarf planet is actually a cryovolcanic hotspot covering an area of 350 square kilometers.
And if it is venting, it could be releasing up to 266 kilograms of gaseous methane every second. We now know gaseous methane is definitely present because the James Webb Space Telescope detected its fluorescence. It might even sustain an ultra-thin atmosphere, which is 100 billion times thinner than Earth's.
That is practically a vacuum. Now, let us talk about its companion. Makemake has only one known moon, provisionally named S 2015-1, or colloquially MK2. Discovered in 2015 by Hubble, it's incredibly dark and about 1,300 times fainter than its parent body. Its orbit suggests Makemake has a high axial tilt.
This tilt means it experiences extreme seasonal changes during its 307-year journey around the Sun. Sadly, because of its extreme distance, currently about 52 astronomical units away, no space probe has ever visited Makemake up close. Even our best telescopes can only resolve it as a star-like point of light. But there is real hope on the horizon. Researchers have already mapped out several highly promising trajectories for a flyby mission. If we launch in the late 2030s using a Jupiter gravity assist, we could arrive at Makemake in about 9 to 16 years. It would be a monumental step in understanding how these distant worlds formed and whether they truly harbor liquid oceans.
It certainly would be a dream come true for planetary scientists and space lovers alike. Well, that brings us to the end of our deep, detailed dive into this dazzling, icy world of Makemake. We hope you thoroughly enjoyed exploring the edge of the solar system with us today.
Thank you so much for tuning in to our show today. Keep looking up, stay incredibly curious, and we will see you here in the next episode. Have a wonderful day, everyone. This episode is based on the Wikipedia article Makemake, which is available under the Creative Commons Attribution Share-alike license. This podcast was crafted using artificial intelligence.